everyone, welcome back to my channel, and in this video we are going to discuss about Naive Bayes classification in data science. So Naive Bayes is we classify the data in data science and it is based upon Bayes theorem. Naive Bayes is a powerful and versatile machine learning algorithm used for classification tasks in data science. It is based on applying Bayes theorem to make prediction with high accuracy and efficiency. Introduction to Naive Bayes. So basically, it is a probabilistic approach. Naive Bayes is a probabilistic classifier that makes predictions based on the probability of each possible outcome, and the probability is a chance of getting the event. Independence assumption. The algorithm assumes that the feature used for a prediction are independent of each other. For example, if we want to classify the email that it is spam or not, so we are using its words like limited offer, buy now, cheap meals. These are the words used by spam emails, and these words are independent of each other. So we make prediction that if the probability of these words are higher, then it is spam, and not, then it is not. So it's totally depend on the independence of the each word. Simple yet powerful. It is a very simple approach and very easy to approach, but yet it gives powerful outcomes and efficient outcomes to the data. Despite its simplicity, Naive Bayes can outperform more complex algorithm in certain scenarios. So basically, assumptions of Naive Bayes. So feature independence. Naive Bayes assumes that the features used for predictions are independent of each other. We, as I said earlier, that the words are independent of each other in an example. So we can understand here that the features should be independent of each other, continuous or discrete features. So if the features are independent, so it can be performed on the continuous or discrete, both the input features. Meaningful priors. Accurate priors probabilities are important for algorithm to make reliable predictions. For example, we make reliable prediction like limited offer, cheap meals. These are the words are the spam emails words. So we make probability. We make prediction that if this word come, then the email is more about this spam emails. If the probability of getting these word is high, then it's a spam email. So first we have to make our prior probability that if the word come, then it's about the spam, and if not, then it's not about the spam. So for this simplicity, Naive Bayes makes prediction based on relatively simple model, which can be both an advantage or a limitation also. So advantages and disadvantages of Naive Bayes. Simple and easy to implement, can handle high dimensional data. Yes, it can handle high dimensional data like just like text. It can easily handle the text data also, require less training data, and performs very well with text classification. And disadvantages of these Naive Bayes. First is assumed data independence of features. Yeah, can be sensitive to feature scaling, assume linearity in the data, may not perform well with complex non-linear relationships. Yes, it can be. And the application of Naive Bayes. The first is email filtering, which we are talking about, identifying identifying spam and sorting emails into relevant folders, medical diagnosis, predicting the likelihood of a patient having a certain disease, risk classification, categorizing documents, articles, or customer reviews, financial forecasting, predicting stock prices, credit risk, and other financial outcomes. So now we are talking about that how Naive Bayes works in the Google Colab. So our first we understand what is Naive Bayes. So we also discussed that Naive Bayes is a method useful for making predictions like guessing if something will happen or not based on past data. Why is it called naive? Because it assumes that all features data points are independent of each other, so one feature does not affect another. This is a bit of naive idea since in real life features might be related, but it makes things simpler and faster to calculate. So how does that work? Naive Bayes work on the idea of probability, means the chance of something happening. With Naive Bayes we can calculate the chance of something happening based on previous example. So now let's use an example. Imagine you have some emails and you want to predict if a new email is spam or not. So step 1 is collect data. First look at the data in the scene. The data is words. In emails, words like buy now or limited offer are more common in spam emails. So in first step, we are going. I'm sorry. So what we are going to do that first we collect the data, means the emails we are going to collect, and then we look at the data. So in the case if the our old data is in words, so we if we get words like buy now, limited offers, then they are more common in spam emails. So our first process is done, that collecting the data and filtering the data. Second is calculate probabilities. We find out how likely it is for certain words to show up in spam emails. For example, if the word offer shows up a lot in spam emails, we calculate that probability. Means if this kind of buy now, limited offers words are more frequent in a spam, so we will calculate their probability. So in step 1 we collect the data, we see the data, and we just filter the data. Now in second step we just going to find out the probability of the spam emails, spam words, and we are going to calculate the probability of high high chances and low chances of spam emails. So in third, multiply probabilities. When you get a new email, look at each word's chances of being in spam emails and multiply this probability is together. If the result is high, it's probability spam. If it's low, it's probability not spam. So in the third step, we are going to multiply the probability of spam of words, and if we got a new email, and if the probability is high, then it's a spam, and the probability of the spam words is low, then it's not a spam email. So our formula is looks like this, that probability of spam upon words is equals to probability of words upon spam into probability of spam, which is whole divided by the probability of word. So this probability formula we also learn in our previous classes. So here we are going to here we are going to implement the probability Naive Bayes theorem by using Python. So now we are going to discuss the email spam is email is spam or not by using an code in Python language. So first we import some packages from first is from sklearn.newbase import multinomia lnb. So we import multinomia lnb class from sklearn.newbase to just text. It is used to text classifier and in emails, and second is from sklearn.features extraction.text import counter vectorizer. So counter vectorizer is also a class of sklearn.feature extraction. So it is used for numerical features, means the words we are going to use in emails are then converted to numerical features, which are very suitable for the data set for the models to perform the algorithm. Now now the part is sample data. So emails is a variable list in which we store our words, email words like buy cheap pills now, limited time offer, buy now, meeting at 3 p.m. Hello friends, how are you? So this is our data set which is going to store in email as list. And the second is labels. We store 1100. Here 1 stands for spam emails and 0 for not spam. Our second step, our step 1 is vectorizer equals to count vectorizer parenthesis. So as I said earlier, count vectorizer is a class. So here vectorizer is an object of the count vectorizer that we create here. And in the next line, features equals to vectorizer dot fit transform emails. So here vectorizer is a class, is an object of count vectorizer class. So and fit transform is also is the method of the count vectorizer. So we call this method by this class, which is vectorizer dot fit transform. And emails is a data set email is a data set we discuss in the code, which we give as an argument in this method, and the output we store in a feature variable. So what fit transform method does? This method learns the vocabulary from the emails and data and transform it into a numerical representation stored in features. Means the words in the emails is stored in the numerical form, and which is suitable for models to perform the algorithm. Now, step 2, model equals to multinomia lnb. Now here multinomia lnb is also a class which is used for text classifier, and model is an object for multinomia lnb we create here. And model dot fit और parenthesis में है features dot label. features dot label हम एज अ आर्ग्यूमेंट देंगे fit मेथड को, जो कि हमने अभी कॉल किए मॉडल 1 पे, और वो मल्टीनोमिया क्लास में जाके अपनी परफॉर्म करेगी, और फीचर्स डॉट लेबल को प्रिडिक्शन के लिए, प्रोबेबिलिटी के लिए आगे भेज देती है. In step 3, test emails equals to get cheap deals now. So get cheap deals now is a new email, so which is stored in test emails variable. Now test features equals to vectorizer dot transform test emails. Now vectorizer is an object and transform is the method which transform the new email we got, test email, which we give as an argument. So it transform the new email by the memory, vocabulary memory it has, and it convert it into a numerical feature which we store in test feature. The vectorizer transform the test email using vocabulary it learns earlier. Prediction equals to model. This is the comment. This is the comment which I make right earlier. So second line is prediction equals to model dot predict test feature. Now this method make a prediction on the test feature. Then we print that is it spam if prediction equals to 1, or else it is not spam. If our prediction comes as a 1, then we print it, and if it is not, then it is not a spam. So if we are going to run it, the output is given is it spam. So what in simple terms this code understand? The code takes some example emails and labels them as spam or not. It then learns which words are commonly found in spam emails. Finally, when given a new email, it uses the learned information to predict if the new email is spam or not based on the word it contains. So finally, we get our output, and fast Naive is very quick and simple, and it works very well with large data. Great for text. It's often used for text classification like detection, spam emails, analyzing sentiments, etc. Thank you for watching this video. This is all about today. Thank you.